So I'm going through a lot of extra effort here to fix the wiring problem, including the stress relief, which pulling on the wires was the problem to begin with. The other side of the capacitor goes to the centrifugal switch, which engages or disengages it depending on motor RPM. You'll see that working later. Building a connection system to connect the capacitor to the electrical case. In this way, it will no longer be hanging by the wires, but rather firmly secured. So both the top and bottom lids are machined for almost a press fit, very firm in the stator housing. That makes sure that the rotor that spins inside stays in a very exact place while it rides on the bearings. You slowly have to work it down because of the tight fit. During the course of this project, I found out that the rotor was hitting the inside of the stator a bit and had to sand it down with emery paper, as it was having a hard time getting spinning after I had disassembled it and put it back together. That's the nature of taking something apart and causing new problems. At the top here you can see the 2 wires that go to the centrifugal switch. I'm going to feed those through to go later to the switch. You'll see. Again, you can see the very tight fit of this lid. I'm hitting it with a special hammer called a dead blow. The inside is filled with little metal BBs. It keeps the hammer from bouncing up and down and damaging the metal. Plus it has a soft surface so you won't crack the cast iron. I'm just slowly working it down. Here you can see the centrifugal switch I'm installing. This is a switch part, and then there's a governor piece that fits on top that pushes down or lets go of the switch depending on shaft RPM. Here's the mechanical part of the centrifugal switch. You can see these lobes, when they hit speed, flip down, which releases the pressure on the switch and disconnects the capacitor from the starting coil on the stator winding. Here's a shot of it in action. You can see what happens. And then as the speed gets too slow, The springs let go, and it's pushing back down the switch for the next time you start it. Let's talk about what went wrong. You'll notice that this picture looks different than the way I had it fully assembled. It didn't actually work right when I first built it. And actually I spent a week troubleshooting it, and I determined 3 main problems. Number 1, the capacitor was bad. It's supposed to be 150 microfarads, and it was measuring in the range of 70 or 80 microfarads. So I think it was degrading all along, and it just had hit the final straw. Problem 2, the rotor was hitting the stator. This is probably due to the fact that when I took it apart originally, the bearings inside the casting got popped out. When I put it back together, they were in a slightly different place and causing some rubbing. So what I ended up doing was spray painting the rotor, putting it inside and spinning it by hand, and then pulling it out to see where it was rubbing. Then I used some emery paper, which is just sanding paper for metal, and sanded down that area of the rotor so it would no longer hit. Problem 3 was I grounded the power plug to the chassis of the motor. For whatever reason, this motor cannot be grounded. Pretty sure it's because it's so old and something's not connected quite right on the inside. But when I grounded the motor and applied power, nothing would happen. So I ended up removing the ground pin completely. That kind of goes against everything I've been taught, but this thing is 31 years old and that's the way it's going to be. Problem 4 was when I originally soldered the lead to the coil. Way back in the first part of the video, I forgot to scrape the insulation off the wire and it wasn't making contact. I think I tore this motor apart at least 15 times till I realized that mistake. It looked shiny, so I thought it would work, but I couldn't figure out why the solder wasn't wicking. Well, that's why. I also added a switch because I was tired of plugging it in every time I wanted to test it. The motor jerks violently when you plug it in when it's on its side, and I just felt better about it this way. So once I got those problems resolved, it was working just fine. So at the end of this video, I'm putting an explanation of how I figured out the wiring for this. My main confusion was why the motor wasn't turning, and I ended up using a multimeter to figure out how the motor was wound, and it seemed to me that there was 3 coils, 2 run coils and an extra start coil. I also figured out how the capacitor connected up through the switch, and once I got done with this mental exercise, I actually understood pretty well how the thing is wired and how it works. I also watched a couple YouTube videos on how induction motors work. Pretty cool, actually. So during the week of troubleshooting and racking my brain trying to understand the problems, I decided to map out the motor. So you saw the post-it note in the first video where I had noted that red and yellow were positive to the wall, and white and gray were neutral to the wall. So I made those 4 things here. I had watched a couple of YouTube videos on how to do this, and basically you just measure each possible combination and see what the resistance is. So I started there. So you'll see here, red to gray was 1.2 ohms, white to yellow was 1.2, and then these 4 paths were all, I marked infinity, that's no connection, infinite resistance. So I know these are my 2 coils. So that kind of makes sense. One of the black wires went straight to the white because it measures 0 ohms. So that's a dead short. There's no coil there. Here's the switch. I knew the capacitor went here. That other side, the repair I did, goes to yellow. So I guess that makes sense to me that one of these 2 drive coils has a capacitor. How exactly that starts the motor, I don't really know. I took a class years ago on motors in college, but I forgot all that stuff. But to me, this diagram kind of makes sense, that you're changing the characteristics of one of the 2 drive coils with a capacitor. That's good enough for me. The other thing was that capacitor, when I measured it, it was 120 microfarads. It says 150 on the side, so that was a little low. So I think that was part of the problem. So I bought a new one, and that came in at 167. So that could be tolerance of the capacitor because they are commercial. I don't know. It was $6, so what the heck. So once I had this in hand and I was sure that my wiring was right, that's when I discovered that I forgot to strip the wire. Once I got that, it would actually start, but it was starting poorly. That's when I discovered the friction problem. I fixed that, and so on and so on. All in all, it was a little frustrating, but I kind of like doing this because now I know how to fix an induction motor. The next time I go see one at a garage sale for 10 bucks, I'll feel better about buying it and tearing the whole thing apart. I would also note that this is my second attempt. The first time I tried to do this to an induction motor, it was to a bench grinder. I destroyed that thing taking it apart, not understanding the thin wires were so delicate. So this time I was a lot more careful, and this time I was successful. Thanks for watching.